topic for discussion next is predicate logic. What we have discussed so far is propositional logic. It is also known as zeroth order logic. With this, we look at propositions like P, Q, and then expressions involving P, Q, something like this, or something like this. Then given an argument involving proportional variables like P and P implies Q and negation Q implies R, does this imply negation R? So something like this. We saw something called tautology, contradiction, implication, equivalence, using which how to check the validity of the argument. So all that we have seen. But there is a limitation to propositional logic, meaning the power of propositional logic. If you look at the power of propositional logic, it is limited. For example, let's look at this statement. Some MTech students are active during problem session. All MTech students have cleared gate. At least two MTech students are good at programming. Suppose I make declarative statements like this. Now, if you see this as a proposition, then if you ask for proportional variables, then you say this statement is P, this statement is Q, this statement is R. So this is perfect, and it's a proposition, and you associate a proportional variable so that if there is a statement like if some MTech students are active during problem session, then so and so. Then you can involve a conditional statement involving P and so on. But if you pay attention to the statement conveys many valid information which will be of use when we start simplifying or when we start proving the validity of a given argument. For example, in this, if you focus on this word sum, it has a meaning and which is crucial at some places. Similarly, all MTech student, all plays a role in some context. Similarly, in this it is at least 2, so which means they are like quantifiers. It is trying to quantify how many students are active during a problem session, how many students have cleared gate, and how many students are good at programming. So in some sense, the number of participants is conveyed as part of the statement, but somehow that is not being taken care when we transform English or natural language to math notation. See, mathematical modeling or abstraction is good as far as simplification and proving validity is all that is concerned. But when we do abstraction or when we do mathematical modeling, our model or abstraction should be close to the reality. It should be as close as possible to what is given to us. In the process of modeling, if we can capture these information, some, all, at least two, so the number of participants involved in this argument, if that is also taken care, then that increases the power of the underlying logical notation or underlying logical expression. So can we increase the power of proportional logic? So can we increase the power of proportional logic so that these quantifiers, right, they are also taken care. Reason they may be of use when we start simplifying the argument. Fine. So that's precisely predicate logic or first order logic. So this logic makes use of quantifiers, because without quantifiers then it is a simple proposition which you can manage, or you can make use of proportional logic and solve. So we work with quantifiers. We work with two quantifiers. One is existential quantifiers. It is denoted using the symbol inverted E. It's called there exist. The other quantifier is universal inverted A. This means for each, for all. Okay. And so this conveys multiple information. Okay. There exist some. Okay. All that is falling into this category. Universal quantifier captures each student in this class, then it's for all. All MTech students, then it is for all. Okay. And some students are good at, there exists a student who is doing so and so. So to capture such statements, we make use of existential quantifier. So we don't simply write P, Q, R. Instead, we write with the help of quantifiers. Okay, so we shall see how to write this using predicate logic. So we need two things. One, predicate, it's predicate logic. So we need predicate that characterizes or that captures the underlying task. In this, it is students and actively participating in problem session. Quantifier will tell you how many are actually participating. And so there is a predicate that represents the student. There is a predicate that talks about student solving the problem. Now we want to know how many students are actually solving the problem. That is the job of quantifier. So the quantifier will tell you how many are actually participating in this process. The process will be described using predicate. In this, students have cleared gate. That's the process. How many have cleared? All of them. And that will be captured by the universal quantifier. So now we will write predicates and quantifiers to capture these statements. So when I say student of X, this is a predicate, which means X is a student. When I say problem session participation of X, which means X is participating in problem session. Okay, so like this we bring appropriate predicates, we rewrite the given expression. We shall now do it for this case study. So to talk about this, we work with an underlying set. It's called universe of discourse. This is our domain. Let's assume the domain is set of students. So to describe any case study, domain is important. Let's assume it is set of students. Then how do we write the first one? So the first one says some MTech students, it is there exist X. Where is X coming from? X belongs to UOD. When we say this, it means there exists X. There exists X in UOD, which means there exists a student. What is the quality of that student? He is an MTech student. So MTech of X. So I define a predicate called MTech of X, which means X is an MTech student. And active participation tutorial. This is my predicate. This predicate says X actively participates in problem session. So if you define appropriate predicate and UOD, our job is done. So this is the formal way of writing or the predicate logic for the given statement. Some MTech students are active during problem session. The word some refers to, it is sum, so we don't know. Is it 1, 2, 10? We don't know. It refers to at least 1. It may be 1, it may be 2, it may be 10, it may be 100. We don't know the exact number. There exists also same thing. When you say there exists X, which means at least 1 X. At least 1 X in UOD, satisfying the property that X is an MTech student and actively participates in problem session. Okay, so if you transform this to this, you see that it is capturing MTech, it is capturing the fact that X is participating actively in problem session and some X are participating. If you simply go for a proportional logic, we simply say it is P. But it is not telling anything about the statement more except the fact that it is a proposition. And this gives you so much. It tells you that X is an MTech student, how many X are participating, and whether X is participating actively in the tutorial or not. Everything is given. So even with predicate logic there are limitations, but it is better than proportional logic. Let's look at this. it's for all. So I say for each x is a student, in particular x is an MTech student. If that's the case, implies x cleared gate. This is a predicate. This predicate says x cleared gate. Okay. Please note, when I use for all, I write implication. When I use there exist, I use and. Make a note of it. We will justify little later. Okay. Let's look at this one. It is asking for at least 2. There exists x, there exists y. X and y may be same, but we want at least 2. So first I say x not equals y. So this will guarantee me x and y are different. So which means we have at least 1. When you come here, it becomes at least 2 and at least 2 MTech students. So x is an MTech student, y is an MTech student, and they are good at programming. So x is good at programming and y is good at programming. So what this says is there are 2 elements in the universe of discourse and they both are MTech students and they are good at programming. It's only at least 2. So you have to maybe more, because there exists tells you at least 1 and this tells you at least 2. Now according to the domain, the way you write changes. For example, if UOD is set of, instead of student, it is set of MTech students, then this becomes there exists x active part tutorial of x. You can drop MTech of x because what you work with is the set of MTech students. Similarly, in this you can drop MTech of x. You can simply say if UOD is set of MTech students, then you say for all x cleared gate of x. So according to the universe of discourse, the expression changes. So to begin writing a predicate logic for a given expression, you should ensure UOD is well defined, predicates are well defined, then focus on the quantifier and the expression. Okay, now this tells you that what we describe is close to what is given to us. Almost everything is captured. And so with this, if you work with this expression, start simplifying, then you may be able to conclude something which may not be possible if you go for straightforward propositional logic. We shall discover more on predicate logic, then look at arguments involving predicates, proposition, and then check for validity of the argument. And you see that propositional logic is a special case of predicate logic wherein there are no quantifiers. Let's explore more.